Yes, ma'am. We can continue, ma'am.
Yeah. Okay. Okay. So, very good evening to everyone. Uh, some of you have already done my class. Some haven't. So, let me first introduce myself. Myself, Dr. Sripona Shaha. Currently, I am associated with the Department of Computer Science and Engineering in your university, Macaut, West Bengal. So, what we are doing, Take 3 has taken this initiative to give you the exposure about different future skills. So currently, 3 different lecture series are going through by this Take 3, where you have enrolled for the lecture that will be on future skills, that is on the introduction regarding AI and ML. So that is, you are going to give certain exposure about artificial intelligence and machine learning. If someone of you have the idea about what is AI, what is ML, then that's very good. If you don't have, then also by 10 days of lectures that we have planned, by that you are going to get the exposure, what is AI, what is ML, and how to apply them. That's the very important question. That is how to apply the algorithm that you have learned in the AI and ML domain in to solve the real life problems. So you can learn different algorithms from the theoretical perspective. But what we are the engineers. So as the engineering from the engineering background, it's very important for all of us to basically apply the learned knowledge for the betterment of the mankind. We need to solve some real life problems. If we cannot solve the real life problems by the algorithms that we have learned, then that knowledge is no use. So what we have planned, these 10 days lectures basically will be divided into 2 parts. In one particular day, one particular theoretical topics will be discussed. Like the last class by your Kamulika ma'am, she has discussed about what is the AI. And what I am going to today, we are going to apply that learned knowledge about AI in the field of healthcare. Today, in this introduction to AI and ML, the subtopic of today's lecture that is on application in the domain of healthcare. That is how the AI and ML algorithms can be applied. So for this particular thing, we'll be starting the screen sharing, and due to the bandwidth problem, I'll be stopping the video. And if during this total lecture, if you find anything doubtful, you can ask in the QA section or you can type your questions in the chat box. So it will be very much helpful for not only to you, but for all of us, if you have can give your views on the AI and ML topic as well as the applications that we are going to talk today. So I'll just going to stop the video and we'll be starting the screen sharing from here. So I'll be starting the screen sharing. So I hope you can just visible here. So that is, this is the today's lecture that we are going to talk today, that is application of AI in healthcare. So what was the last day topic? The last day, your Kamulika ma'am has been given you the introduction about AI and ML. So let's start today's one, that is application of AI in healthcare. So for this application of AI in healthcare, first we are going to have some recapitulation about what is AI. So today's subtopic, that is the application of AI in healthcare. If you just look into this particular title, you can find there are 2 key terms are there. One key term is AI, another key term is healthcare. So what is AI? The full form of AI is artificial intelligence. So now here in the artificial intelligence term, there are 2 words are there. We need to understand first what are the meanings of each of the 2 terms. The first term is the artificial and the second one is the intelligence. So let's come to first the second word, that is the intelligence. What is intelligence? So what happens? There can be some people we can say they are intelligent. So this intelligence is something that you can learn by your birth. There can be certain, and as well as some intelligence that you can acquire by learning something. That is mathematical problem. So how we can learn to solve the problem of calculus? Only by learning those. So that is the intelligence we are talking about. So what we are talking about? We are talking about the human intelligence. What that we have told that the major type of intelligence in the human being that comes from the learning experience. So what is learning? Suppose one pan is in your gas stove and due to the continuous heating of the gas stove, the pan becomes quite hot. Now you are just going to touch that pan and remove it from from the gas stove by your hand. And here your hand is bare-handed. So if the pan is quite hot, then what happens? Your hand might get burned. So by that burning experience, that going to give you the learning experience. By that, from the next time, whenever you are going to touch the pan, you are not going to touch the pan by your bare hand. You are going to use certain type of precautions while handling the hot pan. So that is the learning. That is touching the hot pan and your hand gets burned. By that, we humans learned that if something is very hot, we should not touch with our bare hand. That's one type of learning. So that is the human intelligence we are talking about. So what happens? Scientists have that idea that if we can give this human intelligence to the artificial agents. So what are the artificial agents? So those are basically artificially created. So there can be different types of robots. Now this artificial agent is not only about the hardware robots that we can see, that is the hardware robots are there. Also, there can be some software robots there. Software robot, one particular example, when you are searching in the Google, that's also a type of artificial agent. So that is, if we can transfer the intelligence from the human beings to the artificial ones, then the intelligence that we got, that is basically the artificial intelligence. That is the AI. That is transferring of that intelligence from the humans to the artificially created ones. That is, we have come over here the term of artificial intelligence. Now this artificial intelligence can be divided into 4 quadrants based on thought, behavior, and in the x-axis it can be human and rational. So the first quadrant, it can be that system that think like humans. Then in the second, we can find that is systems that think rationally. Here we can see that the systems that act like humans. Then here systems that act rationally. So we are talking about acting and thinking like humans or in the terms of rational. So this is the 4 quadrants we can have. These are the introduction of the AI. So in the AI in today's world have different applications. The applications range from planning and scheduling different tasks in our factory, where we are supposed to make a autonomous factory and everything is going to be by just the algorithm planning, no human intervention is there. So that is autonomous planning and scheduling of tasks. That is one particular application of AI. AI is also in the chess playing category. In today, in the mobile, you can download different chess games and you can play with the computer. Now, where you are playing with the computer, you can have different levels how you are going to play with the computer. You can play in a very novice way. You can play with the advanced chess players. So there is different algorithms can be developed. That's the playing with the chess game. So we have told about that can be the artificial agents can be hardware, in the software mode. So hardware mode is the autonomous planning and scheduling of tasks. And the soft modes that are the playing the chess game, where there is no actual hardware thing is there. You can just download the software and the artificial agent artificial intelligence is present over there. Another application that is the app cap Uber has developed that thing and it was run in the US, that is the steering a driverless car. So what happens that whenever you are booking the app cab, sometimes the driver calls you and asks you where are you going. And if your answers are not satisfactory to the drivers, they sometimes deny you. And they sometimes say that we need the payment in cash, we need some extra charge. There can be different problems with having a human intervention. Another problem, humans can get tired. So how a human driver can drive? They can drive for around uh, 8 hours, 10 hours maximum. But if we can develop a driverless car that can give you the service 24/7, that's the importance of AI driven cars. Another is understanding language. That's the domain of natural language processing. So in the natural language processing, a very great example, whenever you are saying something like, hey Google, hey Siri, hey Alexa. So these are all the application domains in the natural language processing. Another is in the medical field. That is the robotic assisted surgery can be done using the application of AI. Another is the time series prediction in the stock market. Time series data of the different trades can be fed to the AI algorithm and you can say that which particular stock will go up or which will go in the downside. That are the just a few applications in the AI domain. AI has several applications. It has millions and millions in today's world. Just a few, just to give you that different scopes of AI applications. So today we are going to focus on the application of AI in healthcare. So how that AI can be applied. One particular application of AI in healthcare that we already discussed over here, that is the robotic assisted surgery. But today we are going to talk about something that is very much useful in this pandemic scenario, where we everyone, not only you, that is not only the students, but the faculties and if a different uh, staffs of the university, all of us are doing the work from our home. How we are going this discussion? We are doing this discussion. I am switching on my laptop. You have logged in through your mobiles or through the laptop. If there was no COVID, what would happen? You would have come to our Horinkata campus and there we have a face-to-face communication where we could have discussed this particular topic. But in this lockdown or work from home scenario, what happens? What we need to do? Each and every one of us are bound to work from our home and we are continuously sitting in a particular sitting posture for a long amount of time each and every day. Like just for example, I am doing a course from Jadavpur University Faculty Induction Program, where the course starts from around 10:30, it goes up to 5:30. So that amount of time I am in front of the screen. And again, I am taking this particular lecture. So again, I am in front of the screen. So what happens for each of the day for these continuous from last March in 2020, I am sitting in front of the computer for around each and every day around 7 to 8 hours. Maybe it for the subjects or teaching lectures or for different meetings. So what happens in this particular domain, if we just go over here in this particular thing, that is due to chronic sitting in one particular posture, muscle pains can occur, and that I have experienced, and I think some of you might have experienced that too also. That is, there can be pains at the lower back or in that headaches sometimes happen. So these are some of the symptoms of working from home for a long amount of time. So we are not moving out, we are not doing certain types of exercises, we are all confined at our home. So these are the certain symptoms that develop. So that is basically the motivation of this particular word. So this is one particular application domain of AI that we are going to go through today. Before that, let us go to the background of different application domains only for the healthcare domain. So how the healthcare domain has been enriched by the AI applications by different researchers. So here in the healthcare domain, the major research papers that has been so far done, those are basically the fall detection by gait measurement. So what is the fall detection? Suppose an elderly person is their home and they do not have anyone to attend them and they suddenly falls. So that is fall detection can be done by the camera or different motion sensor devices are there, and then alarms can be generated to the nearby hospital. Then the hospital can come and take care of that fault person, that ill person that can be taken care of. Another in the domain of healthcare, that is the classification using classification of different bodily gestures. There are some basic gestures were there. That is the standing, sitting, and lying. These are the different gestures can be classified in the healthcare domain. These are the core areas of the healthcare domain where AI is applied. Apart from that, some of the other domains that are linked with the healthcare, that is the children's tantrum analysis, another one is the sign language recognition. We have another lecture in the next to next class where sign language recognition will be discussed. That particular application domain will also going to be discussed. Now, in this healthcare, as we are talking something about the healthcare, what we need large number of gestures. As we are doing this in the terms of the gesture recognition, that is, we'll be going through the different person gestures, and by looking at the gestures, we need to suggest that whether they are having certain types of disorders or ailment or not. So we a large number of gestures. So what happens when you gather this type of data? So that total data set, what you need to do in this AI and ML domain, you need to divide the data into three parts. What will be your training data? Another one is your validation data, and the last will be the testing data. Now, the learning can be of two types. One is the classification or the supervised learning. Another is the unsupervised learning that is known as the clustering. So for the supervised learning, so the data that are present in the training data set, they will be mapped or they will be attached with the class levels. So that's the beauty of doing the classification. Mapping of the features from each of the data with their corresponding class levels. If you can do that properly, then your classification accuracy will be very high for the training data set. So in the training data set, you have so you are doing the gesture recognition. So in the training data set, all of the gestures will be mapped with their corresponding class levels for the training data set when we are doing the supervised learning. After that, to validate our classification, we need a validation data set. And last, we need the testing data set. In the testing data set, we do not have the class levels and we need to identify the gestures. So that's the testing data set. And we are doing this particular application in the domain of healthcare. So whenever you, suppose you are going to do something in the healthcare domain, whether any type of healthcare related domain where not only the healthcare, you can do certain types of work that related with human beings. You need to data from the human beings directly. In each of the times, you need to have the proper medical knowledge. Always have the medical knowledge with you, and for the medical knowledge, we always need medical practitioners. Without taking the help of medical practitioners, do not go and do any type of work related to the healthcare domain. It will not be properly fruitful. And any type of classification or clusterings, whatever you are doing, we need to have a high accuracy and in short time. And this accuracy is very vital for the healthcare domain particularly. Why? In the healthcare, it's very much vital to recognize the particular disorders correctly. Suppose one person has disorder 1 and you have been identify it with the disorder 2, then extreme wrong diagnosis is there. Or suppose one person has a disorder and you have given him that no, you don't have any type of disorder, then also it will be very much bad for the society actually. So we need a high accuracy and the result we should get in a short time span. So this is the background of doing anything in the healthcare domain. And what we'll be doing, or in this particular work, what we have done, we are to focus on recognizing the gestures. And here, each of the gestures will be associated with some of the disorders. So these particular over here, so this particular is basically the disorders that is related to the back. This is basically the headache. This is basically pain at the knee, and this is basically pain at the hand. So you can just see that is by just looking at the gestures. By just looking at the gestures, we can say that is what type of disorder might be. And that is the human intelligence we are talking about. That by looking at the figures, the humans can say what type of disorder it is. But whether the computer can do it, that we need to do. So we need to make the AI over here. And so there are several causes of these disorders that can be injury, fatigue, and aging. So this particular work is published much before this COVID-19 pandemic. So these were the certain types of causes. So in today, we can say the cause of these disorders can be working from home for a longer duration of time. And here, the disorders are further intensified due to sedentary lifestyle of the individuals. And early stage symptoms of diseases we need to monitor and make the subject aware of the deteriorating health. So that's the idea. That's the aim of this work. So what we are trying to do will be suggesting the subjects. So what are the subjects? So from those persons, we are going to take the data. So those are the subjects. Our aim is to say to the persons that, see, you have this particular disorder. Suppose you have the back pain. So we will be making aware that subject, and we are going to suggest certain type of exercises after consultation with the medical practitioners. So that's the motivation of the work. In this particular domain, we have this particular paper that is published in the Springer International Conference. That's the ensemble classifier-based physical disorder recognition system using kinect sensor. This is the one particular paper that is published. And as this is just your second lecture on this particular lecture series, so what I have planned, I am not going to the much deeper of each of the algorithms. What today we are going to do, we are going to have the overall idea about how you can apply AI in the healthcare domain. Just the overall concept, such that when the next time you are planning to work in the domain of AI or ML, then you can have the basic idea that what type of applications and what can be the different type of algorithms. So we are not going into the details of each of the paper. Today in this lecture, we'll be going to have discuss about 3 different lectures. One for this gesture recognition purpose in the healthcare domain, and other 2 are in a different topics, not gestures, but some emotional content that we are going to recognize. So for all of the 3 papers, we are going to have the overall idea of that. And if you find that any of the paper interesting, you can find each of the paper in the internet. You can search by this particular paper name. You can take the screenshot and search it in the internet. In the Google Scholar, you can easily find the papers and you can go through the papers. And if you want to discuss anything regarding any of the paper, you can obviously contact with me. So this is the particular paper currently we are talking about. So anything that you want to do in the particular AI ML domain, what you need to do? So you need to first prepare the data set. And here we are going to recognize the disorder, that is the physical disorders that will be related to certain gestures. So we have to create a certain type of data set using this particular domain. After that, you need to design a proper classifier. In this particular algorithm that is published in this paper, that we have designed an ensemble. You can go for any other type of classifier as well. So we need a data set. The data set will be divided into three parts: training, validation, and testing. Then we need the algorithm by which we are going to do the classification. And after that, the experimental results should be properly discussed. That's a very vital part of publishing any paper. Whenever you are going to publish any research article, you need to give a high amount of focus in doing this particular. Proper result should be given, and the result should be compared with the already published papers. That's another vital thing. You can get the accuracy of 90%, and you can say, oh God, great, I got 90% accuracy, so my paper must have been very great. But it might be that the earlier researchers in this particular domain has already published papers where their accuracy is more than 90%. So then your result basically becomes of no use. So comparative study is very important in this experimental results domain. And then you have to conclude your research work. That is why we have divided this total paper into basically four different parts. That is creating of the data set, and then application of the designing of the algorithm, then the experimental results, and then conclusion. So this is this particular paper. So that is how you can apply AI in the healthcare domain, where the healthcare we are talking about, that is basically the different types of gestures. This is one. And another type of application that will be moving on now. That's also very important. And I think you will be very much familiar with this particular application, then I can be much more familiar with this application. So you might know your senior Joy Karia. He has published this paper that's published in the Indicon conference. That's the IEEE International Conference. So in this paper, what we have done, we have analyzed the adverse gaming effects. So that's why I've told you that you will be much more familiar with this particular topic. So you are playing the Android games for a longer duration of time, and how your emotional contents are changing each and every day, that you never have thought about. You have never think that is okay, so I am investing 3 hours each and every day playing a certain game. So have you ever noticed how your emotions are changing each and every day? That we don't do. So that is, we are going to analyze the adverse gaming effects on emotions using neural networks based hybrid architecture. So for this particular lecture, that is today's lecture, we are not going to talk about the neural network part. We'll be just going to understand how this particular application domain can be formed. So from next time onwards, whenever you got a proper application domain, so you find one particular application domain, and this application domain, suppose you want to apply your AI, so how you can develop your total research work. Basically, that will be our concern. That is, whenever you are going to designing anything, you need to publish this. Without the publication, that's of no use. So when you are publishing the paper, how can properly write that paper in such a fashion that it can be internationally acclaimed one. So that we are trying to do. So these are the different contents that's in our paper. You can here, you can just find a certain similarity with the earlier paper that we have discussed. In the earlier one, there also was introduction about the physical disorders related gestures. Here also there is an introduction. In the earlier paper, we have talked about the ensemble classifier. Here will be, that's the algorithm in the previous paper by which we have done the classification. Similar way, here we are going to have the today's application, that is with the hybrid architecture of the neural network, that we are going to uh, propose in the second part. And in the third part of the paper, in the earlier same way, we are going to give the experimental results, and the four, in the similar fashion, we have given the conclusion and the future direction. So we are now talking about the introduction of this work. So I have given you a brief idea about what the paper is all about. So a few years earlier, you must have seen this type of news articles. That is, by just playing video games, people are committing suicides, or there might be certain heart attacks in the people. So that is, deaths are coming by just playing video games. So by just doing that, your emotional content is changed in such a fashion that people commit suicide. That's quite a shocking thing. So that gives us the motivation of doing this particular research work. So these are some of the published papers. And if you just notice each of the papers, you can download the paper. And for each of the paper, basically, these are all the psychological aspects of the changes of human emotional content by playing the game. So these are all the papers in the domain of psychology. From the engineering perspective, this is the first paper where we have discussed about the changes in the emotional content by playing the video game. So these are the some other papers. So what we can do by doing this particular work, we can give parental control that can be achieved. And in this particular work, what we have done, while you are playing the game, the front camera can get activated. And by that front camera, the image can be captured. That is, in your mobile, you have a front camera and you are playing the game. So your front camera gets activated automatically. We can develop an app in such a fashion. And after activation of the front camera, your facial image can be captured. And by the facial image, the emotion can be recognized. And if any negative impacts can be classified from the facial image, then alarm can be generated. So alarms can be generated to the parents as well. So this is what we are doing. That is, the subjects will be playing video games. And while playing the video games, the front camera will take the images. So after that, we are told that certain alarms will be generated. What type of alarms we can give? One is we can give the parents certain news about that your particular child has getting this type of emotional negative emotions after playing this game. That type of report we can generate. So generation of this report, that will be just for one particular child and to their parent. But suppose we want to publish those type of reports, we can publish this type of way. So in the Google, whenever you are going to try to in the Google Play Store, if you go and you are trying to find any type of app, so you can find this type of ratings are there. What is the meaning of this type of rating? So meaning of this type of rating is that how much likely this particular game is. So it's PUBG. You know very well than me that what PUBG is. I have never played it, but you might have played it. So you can give ratings to that game. How are liking this game? But liking of this game is not equal to the thing of how much emotional content is going to be changed by that game. So we can give another rating over here that can suggest that playing this game will give positive emotions or the negative emotions. That we can do. So we can give ratings in the terms of emotional content changing for each of the apps that are not here apps. We are talking about the um, gaming apps here. We can give ratings to the gaming apps that we have proposed in this particular paper. So this is basically the proposed hybrid architecture we are talking about. So we can say one person is playing the game, and while playing the game, the facial image is captured, and after the facial image is captured, certain features need to be calculated. So from any of the data set, whether it's an image or it's not the image, any type of data, we need certain types of features. So the features are basically by which that particular data can be separated from other data. And if suppose there are 10 number of data that belongs to class 1, so all of their patterns from the features will be same, or it should be aligned features for the data that belong to one particular class. And the patterns for the data that belong to one particular class to another particular class, the pattern will be completely different. That's the thing. So we are going to here capture the facial images, and after capturing of the facial images, features will be calculated. Here the features are basically a heart-like features. And after that, classification is done. So first classification, that is the BPNN, by which BPNN, that is back propagation neural network. So in one of the lectures by your Kamalika ma'am, she is going to introduce to you about the neural network and the back propagation in the neural network. So till that day, we are not discussing this particular thing. So is what we are doing over here, that you can understand here. That is, suppose the camera is gets activated and the camera is taken one particular image. Now that image might contain a face or not contain a face. So if the image does not contain the facial expression, we need to discard that image. So if one image has got the facial expression in it, then we need to take those images. So the first stage of classification using PPNN, that is to identify those images which have the facial expressions in it. So that is the first utility of doing this first stage of classification. After the images with the facial expressions that are separated from the all the images that are captured by the front camera of the mobile. From that, the second stage of classification using the same algorithm, that is the BPNN, we need to identify the facial expression into 5 classes. Here you can check the classes are from positive emotions to the negative emotions. Happy and surprise. These are the two positive emotions. You are playing one game that's health. Then happy will be generated. After playing the game, you are getting certain types of rewards by the game, certain types of pop-ups of game, and you got, suppose you create the highest score. That's going to give you the surprise emotion. Now you are playing a game and you are not quite excited about that game, so you can get the neutral emotion. But this is all about the good effects of playing the game. In the negative part, that playing the game, there are certain games that we have encountered in the Google apps that are freely downloadable, but due to the violent nature of the games, they can generate sad and angry emotions in the children. So that is, the games can generate the positive emotions as well as the negative emotions. And by this proposed hybrid architecture, we can classify the captured facial image and then classify it into 5 classes. That is from happy to angry. So 5 classes we're going to classify the image. And based on that, score can be calculated. That is for each of the day, we are taking the count of how many happy emotions are generated, how many surprise emotions are generated, as well as neutral, sad, and angry. For each of the day, we can create a bar chart which shows which emotions are generated and how many number of times on that particular day. For the day number 50, these are the bar chart representation of 5 of the emojis. So that is the emotions that is for the happy emotion. This is for the surprise. This is the neutral. This is the sad, and this is for the angry. So for each of the emotions, different day-wise ratings you can get. Based on that, scores can be calculated. This is one particular one that we have done. So these particular, I am not going into the much details of the highlight feature generation and how to implement the domain. Just for the experimental result first, we'll just come over here. So here, what we have done, we have for each of the day, we have calculated the average values of each emotion and are plotted using bar charts. They have already discussed. Then we have asked the participants to play two distinct type of video games for 30 days. So one video game is Candy Crush Saga and another video game is Stickman Arcos. For each of the two video games, the participants, that the subjects, have been played these two types of game for 30 days of duration. And these two games, for each of the two games, for each of the day, the subjects, that is, they are playing for the 30 days, and for each of the day, they are playing for 30 minutes of duration. And for interval of every 20 seconds, the emotions are calculated. How the emotions are calculated? That is based on the hybrid architecture that is already been discussed. So each of the day, one particular subject is playing for 30 minutes. And for 30 days of duration, they are playing. And at each of every 20 seconds, emotion is calculated. Now the games can have distinct effects on human emotions. But negative contents of games affect human brain much more than positive ones. That's the thing we have noticed. That is, the angry and sad emotions are going to predominate the positive emotions like happiness and surprise. That is the experimental results we have found. So for two different type of database, we have already told we need a data, huge amount of data we need. So this is the two different database. One is already available in the internet, freely downloadable. And another is from the database we have created in our university, for which we have mentioned how many number of days participants have been played and what's the criteria for that we have discussed. And this is basically the accuracy we have got. So already told we need a high accuracy. And we need to compare the obtained accuracy with the already available accuracy in this particular domain. But what happens, this is basically the first paper in this particular domain of recognizing the emotions while playing the video game. So we do not have other comparative results. And for these of the two games, that is the Candy Crush Saga and Stickman Archer, these are the graphical view of effects of the video games on human emotions. Here you can check, that is for the day number 30 here, the positive emotions are more. And here in the day number 30 for this particular Stickman Archer, the negative emotions are predominant over the positive emotion. This is we have noticed for this research work. So that are the different conclusions that we have already told. For this particular work, what is the future direction we can go? So we have done this work for taking the frontal image, or that is the frontal facial image basically of the subject by the frontal camera of the mobile. So if the participant is playing the game in a lighting condition where the facial cannot be properly recognized, that can be one thing. Or it can be like they are any other persons are playing the game and the rating are generated for that person for which the mobile belongs. So there can be different disadvantage of doing this image processing and from images while we're capturing or recognizing the emotion. So we in the next step, in the next paper that we are going to talk now, for there we have taken the EEG signal, that is electroencephalograph signal, and from that emotional changes are measured. So this paper is published by the IEEE International Conference Connect, and this particular paper, the emotional changes when playing video game, that has been discussed while taking the data of the EEG signals. So we are just going to the part this type of already been discussed. So this is the particular proposed work. So again, for this particular work, we have taken one particular data, and from that particular data, we have processed the data, and from the processed data, processing is done using the filtering and artifact removal. It's the easy signals and how the filtering has, it's a time series data, easy. So for any type of time series data, we can apply the filtering process, as well as artifact need to be removed from that data. That is the three processing stages that has been done. What's artifact? Basically, whenever you are moving or blinking your eyes, basically, or you are moving the hands like that, so then certain type of signal disruption can be done. That are basically the artifacts. So we need to remove that. After that, features need to be extracted. So now you can find a similarity with the earlier work. That is, features can be need to be extracted properly. After that, a classification is done. Then after the classification, we are measuring the cognitive load. So that how much effect that game has on our brain. And based on the cognitive load, rating of the game is given. So this is basically the experimental setup. This is in our Horinkata campus. Horinkata campus, thanks to our honorable Vice Chancellor Sir, Professor Dr. Soikos Moestro, and to our registered sir. This is the university seed money. From the university seed money, I can procure this particular machine, and if you can come to the human computer interaction lab that is in the academic building of the Horinkata campus, you can find this particular EEG machine is there. So this is a BrainTech EEG machine that is we have already have in our campus. In this particular EEG machine, our participant is giving the data while playing the game. Here you can see the participant is playing the game in her mobile, and from the brain the EEG signal. So what is the EEG signals? EEG is basically measurements of the brain activity level, how the brain basically functions. That can be measured by the electrode placed using the EEG sensor. So how many electrodes are there? In this particular machine that I have procured here, I have 21 EEG, 21 channel EEG sensor is there. So from each of the electrode, here you can check this is the electrode. So for each of the electrodes, brain activity levels can be captured in the by the terms of electrical impulses. And these based on these, the graphs of how the each of the electrode data is moving with respect to time. If you can just check over here, just very closely you can look. This is the how the each of the signals are fluctuating with respect to time. So this is the time series data that we have captured using this BrainTech EEG sensor. For this particular experiment, we have taken the data for 12 subjects, and they have been asked to play the game Brain It On. The name of the game that is the Brain It On, and how the each of the level of that game Brain It On, and for each of the level how much cognitive load are generated in the participants, that we have tried to measure over here. So this is the EEG acquisition process. So these are the pre-processing and feature extraction for the EEG signals. We are not going to the details of that. So what happens whenever you are going to play the game? So this particular game is Brain It On. This particular game is basically going to give you different types of puzzles, and you have to solve those puzzles to succeed that level. So you have to solve the puzzles. So whenever you are seeing the puzzle, what happens? First, the occipital lobe at your brain is activated. Occipital, as the name suggests, it basically deals with the eyes. So in the eyes, so you are just checking the game. So your eyes lobe, that is the lobe that is associated with your eye function, that is the occipital lobe, that is first gets activated. So this is the brain map. In the brain tech traveler system itself, you can get this type of brain map. If you are not getting, there is another software for e-Loretta. From that also, from there also, you can get this type of brain map. And here in the brain map, you can just check this orange line. So orange means over here that is a highly activated region. That is the levels of the region, how much active that particular region. And in your brain, this is basically the occipital lobe region. So now you can check this is the eye portions in the brain, that the occipital lobe is activated. Next, what happens? The participants need to uh, solve the particular puzzle. For that, brain is going to try to fetch the solution. For that, for doing that, the prefrontal lobe gets activated. And from this brain map, you can check the prefrontal lobe is activated, as this is basically based these particular colors that are over here. So from this color, but you need to match to the brain map over here. So blue, this is the blue region, that is basically the low activation region. This is basically the medial activation region, and high, that is the red and the orange. These are basically the highly activated region. So prefrontal lobe is activated. So after the occipital lobe, the prefrontal lobe is activated. And how that, what are the functionings of the loops? How many loops are there in the brain? For that, you have to study the brain component. If you are planning to do works in the EEG domain, you need to understand the brain functioning. Basic brain functioning, without having that knowledge, you cannot do EEG related work. After that, our prefrontal region gets activated while thinking and planning to execute the solution. This is the region in the prefrontal lobe that is now activated, and by that we can just check that image and just check over here, that is from occipital to prefrontal to parietal. This is how different lobes will be activated, and that can also be checked over here. So these are the time series data that we have captured by the brain tech traveler, that is the different brain map, and that also uh, gives satisfied to our this particular activation with respect to time. That is, with respect to time, how different lobes are getting activated, that you can check from the brain maps as well. So then this particular algorithm, that is, we have already told, that is, we need a training data set and a testing data set. So these are the training and the testing data set, accuracy level for all the 12 subjects. We have 12 subject data and different cognitive loads. How many cognitive loads are there? So basically, there are three cognitive loads: high, medium, and low. So for three cognitive load, we need to classify the cognitive load into any of the three cognitive load category. So how many classes we have? We have three classes: high, medium, and low. So that is the training and testing accuracy for each of the subject for the each of the cognitive load class. This is the average result, and this particular algorithm has been compared with, that is, we have proposed this algorithm using the backpropagation neural network. As already discussed, this particular any type of algorithm, when you are going to propose that algorithm, we need to compare the result of that algorithm with the so as already told, this type of works are the first in this domain where the subject data has been considered while they are playing the video game. So we have compared with the other algorithms that are available, and very famous algorithm SVM, KNN, LBA, and QGA. So that we have done. So what's the full form of? That is here written over here. SVM is support vector machine, KNN, K nearest neighbor, linear discriminant analysis is LDA, and quadratic discriminant analysis is QDA. So these are the different algorithm levels we have done. Now only comparison one particular start with different algorithms, that's not enough. We need to statistically justify our work. So we have done the maximum test by which we have statistically rejected the null hypothesis when comparing with the control algorithm with the competitor algorithm that we have done. So this is the summarization of the work. So that we have already discussed, that is the person's changes in the emotional content or here the cognitive load that we can measure. By that we have divided earlier case, we have divided the emotions into 5 different classes, 2 from the positive, 2 from the negative, and 1 was the neutral. And here we have classified the cognitive loads into low, medium, and high category. These are very much useful for the parental guidance. Apart from that, this particular application is useful in the gaming perspective that we already told. It has the applications for social media. When you are doing the social media surfing, how the cognitive loads are generating. That's another particular research work that you can do. So this particular research work has application in the cybersecurity as well. So why cybersecurity? We have already told for the Momo games, that is the different children have committed suicide. That is only playing games, suicides, that deaths are happening. So for the cybersecurity as well, these particular algorithms can have their application. So different references are there. So if you can want to go through the reference, it will be better. If you just go through the references of each of the papers, we have today discussed about 3 different research papers. So now it's time for the question answers. If you have any doubts regarding anything, you want any clarification, you can ask the clarification in the chat window as well as in the QA section. So in the chat, we have got one particular question that I'm going to take now. That is, what is training data set? Okay, so you are designing one particular algorithm. The algorithm can be a classification algorithm or a clustering algorithm. So the algorithm, we need to train that algorithm. So for training of anything, we need a type of data. That's the trained data. As the name suggests, that is, the trained data means the data by which you can train your proposed algorithm. That is the trained data. Now, by the data set by which you can validate your algorithm, that is basically the validation data set. That is, you have trained the system. Now you want to validate the results of the system. That is the validation data set. And before giving the data to the real world, where any algorithm is developed and that has been given in the market, so that is the testing data set by which we are going to test our algorithm. So that is different. I hope you understand. Any doubts you have, you can ask in the chat window or in the Q&A.
Dear students, if you have question, you can post it down. You can post it in the question answer section or in the chat box. It is now open for question answer session. If you have any query or you want to know any information, you may ask your question